This video is for section 4-10, the factor theorem. Here's a question. Is x minus 2 a factor of polynomial p in the first column of the chart below? In the chart, there are 4 different polynomials in the first column. It's blurry on the video. Hopefully it's readable on your note page. The first part where it's all blurry, this is x squared, this is x squared, this one here is x cubed, and this one here is x cubed. Does x minus 2 divide evenly into any of these 4 polynomials? To figure out if it does, we would do long division. When this first polynomial is divided by x minus 2, the answer is x plus 1 with a remainder of -4. When the second polynomial is divided by x minus 2, the answer is x minus 3 with a remainder of 0. Here we see the quotient and remainders for those next 2 polynomials. And the question was, is x minus 2 a factor of p? It is not a factor of the first one because the remainder is not 0. It is a factor of the second polynomial because the remainder is 0. Same for the third, and then in the fourth we see that it is not a factor. So to decide if a binomial is a factor of a polynomial, you could use division and look at the remainder. Here's a follow-up question. True or false? X minus 2 is a factor of polynomial p if the remainder is 0. Hopefully you put true for that. Next, look at the last column of this chart, where p of 2 is evaluated for each polynomial. P of 2 means to substitute 2 in place of x and to find the value. What do you notice about the results? In the polynomial x squared minus x minus 6, when you substitute 2, it becomes 2 squared minus 2 minus 6. And that answer is -4. Look what remainder we got when we did division. In the second polynomial, x squared minus 5x plus 6, when you put in a 2, you get an answer of 0. Look what our remainder was when we did division. Do you see a connection there? The remainder you get when you divide by x minus 2 is the same number as the answer you get when you substitute in 2 for x. That's what the factor theorem is about. If p is any polynomial with the letter x in it, then x minus a is a factor of p if and only if p of a equals 0. Let's say we have some polynomial. X minus 6 would be a factor of the polynomial if p of 6 turned out to be 0. Or let's say we have some other polynomial. X take away 3 would be a factor if p of 3 turned out to be 0. So the factor theorem connects factoring to substituting numbers in place of x and evaluating answers. With the factor theorem, we can factor polynomials that don't fit one of our previous patterns. Prior to today's lesson, we haven't been able to factor a trinomial like this that has a third power in it. By applying the factor theorem, we can. Let's figure out one of the factors of the polynomial using substitutions. Perhaps one of the factors is 1. Let's evaluate p of 1 and see if we get a remainder of 0. Substitute 1 for x and figure out the answer. 1 cubed is 1. 3 times 1 is 3. And when you combine these numbers together, you get an answer of 0. Because p of 1 makes 0, we know that one factor of the polynomial is x take away the 1. I tried 1 because it's an easy number to do math with, and 1 is a factor of the constant term 2. If that had not resulted in an answer of 0, I would have tried substituting a different number in for x, another number that is a factor of 2, for example 2, or negative numbers such as -1 or -2. Because we have figured out one of the factors successfully, we can now use long division to find the other factors. X minus 1 divides into x cubed plus 0x squared minus 3x plus 2. Now perform long division to see what corresponding factor we get written on top. X times x squared makes the x cubed. X squared times negative 1 is negative x squared. Now subtract. 0x squared subtract negative x squared is 1x squared. Bring down the minus 3x. X times positive x makes positive x squared. X times negative 1 is negative 1x. Now subtract. Negative 3x subtract negative 1x is negative 2x. And bring down the positive 2. X times minus 2 is negative 2x. And negative 2 times negative 1 is positive 2. When you subtract, you get 0. We expected to get 0 because we knew ahead of time that x minus 1 was a factor. The reason for doing the long division is to create this. The thing that is multiplied to the x minus 1 to make the original polynomial. We know how to factor x squared plus x minus 2. It will factor with a double parenthesis pattern. X times x is the x squared, and positive 2 times negative 1 makes the negative 2. Let's write the final answer right here. Polynomial we were given factors into x minus 1 squared times x plus 2. Why did I write x minus 1 squared? Do you see where there are two x minus 1 factors? We figured out x minus 1 was a factor in the first step, and then later we got another x minus 1 factor. Here's another example. Is x plus 3 a factor of this polynomial? One way to find the answer is to divide by x plus 3. If we get a remainder of 0, then it is a factor. But long division is a lot of work. Let's use the factor theorem. X plus 3 is equivalent to x subtract negative 3. That fits the factor theorem. Remember x minus a? So let's substitute negative 3 in place of x. Every place where there's an x, fill in negative 3. And let's figure out what this makes. If it makes 0, will you answer this question yes or no? All right, let's find out if we get 0. Negative 3 to the 4th power is positive 81. Negative 3 to the 3rd power is negative 27, which multiplies to this negative 3 to make positive 81. 9 times negative 3 is negative 27, and on the end there's another negative 27. We could figure out what this makes, but is it evident that it does not make 0? So the answer is no. Because substituting negative 3 for x does not make an answer of 0, we know that x plus 3 is not a factor. Let's try one more example. This time we'll factor this polynomial. There's not a GCF in all terms, and if we try to group the first two and the last two together, it doesn't look like that will get us anywhere either. So let's use the factor theorem to find us a factor to get started with. What is P of 1? This makes negative 60. What is P of 3? With the help from a calculator, this makes 0. Because this makes 0, v minus 3 is a factor of the polynomial. Now let's divide the polynomial by that factor to get its corresponding polynomial. V times 14v squared makes 14v cubed. And 14v squared times negative 3 is negative 42v squared. Now subtract. Negative 23 subtract negative 42 is 19v squared. Bring down the negative 60v. V times positive 19v makes 19v squared. And 19v times negative 3 makes negative 57v. Now subtract. Negative 60 subtract negative 57 is negative 3v. Bring down the positive 9. V times negative 3 makes negative 3v. And negative 3 times negative 3 is positive 9. When you subtract, we get the expected remainder of 0. Again, the reason for doing the division is to create this up here, which is a quadratic trinomial. We know how to factor quadratic trinomials. Double parentheses. Something times something to make 14v squared. There are different possibilities. Let's try 7v times 2v. Then, something times something to make negative 3. It could be positive 3 and negative 1, or negative 3 and positive 1. Pick one of the pairs of numbers and substitute into the blank places. I'm going to try a negative 1 here and a positive 3 here. The outer product is 21v. The inner product is negative 2v. These combine together to make 19v. Here's the factored form for the original polynomial. V minus 3 times 7v minus 1 times 2v plus 3. Let's summarize the lesson. We discussed the factor theorem, which makes a connection between dividing and getting a remainder of 0 and substituting and getting a value of 0. The factor theorem gives you another way to figure out a factor of a polynomial. And it expands the kinds of polynomials that you can factor because it gives you a technique to get started with your factoring.